Welcome students. Good morning. Today we study revisiting decimal representation of rational numbers. In previous class we have learned that all the rational numbers have either a terminating decimal representation or a non-terminating repeating or recurring decimal representation. Under this section, we will study the condition for a rational number p by q, where q is not equal to 0, be terminating, and condition for it to be non-terminating recurring decimal. Now, in this regard, we study the two theorems. This theorem 1, let x is equal to p by q be a rational number such that the prime factorization of q is in the form of 2 power m into 5 power n, where m and n are non-negative integers. Then x has terminating decimal. Now see the meaning of this. Let p by q is a rational number. You will write the prime factor of q. If prime factorization of q contains only either 2 or 5 or both 2 and 5, that is, this p by q has terminating decimal. Now next theorem. This x equal to p by q be a rational number such that prime factorization of q is not in the form of 2 power m into 5 power n, where m and n are non-negative integers. Then x has non-terminating recurring or repeating decimal. Now see the meaning. This p by q is a rational number. You will write the prime factor of this q if the prime factor of q contains any other prime number with 2 or 5, then decimal expansion of this will be non-terminating recurring. Now q का हम प्राइम फैक्टराइजेशन लिखेंगे. q के प्राइम फैक्टराइजेशन में यदि 2 और 5 इन दोनों के अलावा भी कोई प्राइम नंबर आता है, जैसे 3 आ जाए, 7 आ जाए या कोई और प्राइम नंबर भी आ जाता है, इसका मतलब ये है कि ये p by q रैशनल नंबर, इसका डेसिमल एक्सपेंशन नॉन टर्मिनेटिंग रेकरिंग होगा. Now question number 1. Without actually performing the division, say the kind of decimal the following rational numbers have. Number 1, 13 by 3125. First of all, you will see this denominator 3125 and writes its prime factorization. 3125 writes its prime factor. 3125, it is divisible by 5. Divided by 5. Divide this 31 by 5. 5 6 are 30, 1 12, 5 2 are 10, 2 25, 5 5 are 25. Again divided by 5. 5 1 are 5, 1 12, 5 2 are 10, 2 25, 5 5 are 25. Again divided by 5. 5 2 are 10, 5 5 are 25. 5 5 are 25, 5 1 are 5. Then it is 5 is present 5 times, then you will write 5 power 5. 2 is not present here, then you can write 2 power 0 into 5 power 5. Now see, in the prime factor of this 3125, the prime factor 5 is only present. That is, from the above theorem, you can say that this 13 by 3125 has terminating decimal. Since the prime factor of 3125 is in the form of of 2 power m into 5 power n, where m and n are non-negative integers. Therefore, 13 by 3125 has terminating decimal. Number 2. 17 by 8. You will solve this question also. This question same as number 1. You will write the prime factor of 8. 8, it is divisible by 2. 2 4 ja 8. 2 2 ja 4. 2 1 ja 2. Then 2 present 3 times. Then you can write 2 power 3. You can write this as 2 power 3 into 5 is not present here. Then you can write 5 power 0. Since the prime factor of 8 is in the form 2 power m into 5 power n, therefore 17 by 8 has terminating decimal. Number 3. 64 by 455. 455 equal to prime factor of 455. It is divisible by 5, divided by 5. 5 9 ja 45. 5 1 ja 5. It is 91 divisible by 7. 7 1 ja 7. 2 21. 7 3 ja 21. 13 itself a prime number. It is divisible by 13. Then it is 5 into 7 into 13. You can write this as 2 power 0 into 5 power 1 into 7 into 13. Now see, in this prime factor, 2 and 5 both are present, but other prime numbers 7 and 13 are also present here. Therefore, the decimal expansion of this 64 by 455, it is non-terminating recurring. Since the prime factor of 455 contains the prime number seven and 13 also, therefore 64 by 455 has non-terminating recurring decimal. In this way, you will solve the remaining questions of question number 1. Now question number 4, 15 by 1600. 1600, write its prime factor like this, 1600 divided by 2, 2 8 is 16, 200, 200. Again divided by 2, 2 4 is 8, 200, 200. Divided by 2 again, 2 2 is 4, 200, 200. 2 1 is 2, 200, 200. Divide it by 2 again. 2 5s are 10. 2 5s are 10. 2 0 0. Now divide it by 2. 2 2s are 4. 1 10. 2 5s are 10. Divide it by 5. 5 5s are 25. 5 5s are 25. Now 5 1s are 5. Therefore, 2 present 6 times, then 2 power 6 into 5 power 2. Now prime factor of this is in the form of 2 power m into 5 power n. Therefore, this 15 by 1600 has terminating decimal. Now you have to solve the question from 5 to 10 of question number 1 in the same way. If prime factorization of the denominator is in the form of this 2 power m into 5 power n, then you will say terminating decimal. And if any other prime number also present in that factor, then you will say this one has non-terminating recurring decimal expansion.